Hello everyone, myself Pushpalata, Assistant Professor SJBIT. Today we'll be discussing about the core subject of Electronics and Communication Engineering, Microcontroller. The subject code is 18EC46. Basically, this subject enables the students to understand the basic concepts of microcontroller, and we will be studying about the difference between microprocessor and microcontroller, the basics of embedded systems, embedded controllers, and also we'll be studying about the different architectures of computer like RISC, CISC, Harvard, von Neumann. And in the second module, we'll be familiarizing about the different instruction set and basic architecture of 8051 microcontroller. Specifically, we are going to study about the features, architectures, and internal organization of 8051 microcontroller. In the module 3, we are going to study about some of the programs using assembly level language and C programming. Using the instruction set, we will be able to write some simple programs using low level and high level languages. And in module 4, we will be in depth of analysis. We will be analyzing about the interrupts of 8051, what are the uses of interrupts, and how we are going to use these interrupts in our program. And the last module, and we also been studying about the different timers and counters and serial communication, okay, serial data communication, and we'll also be writing small programs in order to communicate serially. The last module is completely about interfacing of 8051 with external devices, I/O devices, or to external memory using I/O ports. Here we will be able to write small programs in order to interface to LCD converters like analog to digital or digital to analog, and we'll also be interfacing with stepper motors, like that. Small programs we'll try to write for in order to interface 8051 with other external devices. This is the syllabus where we will be studying in different modules. Module 1 comprises of 8051 microcontroller, introduction, differentiation between the microprocessor and microcontroller, basic concepts of 8051 architecture, register, pin diagram, I/O ports, and we'll also be studying about the internal memory and the external memory organization. In module 2, we'll be talking about the different modes of addressing your controller and different types of instruction set, data transfer instruction, where you will be moving the data from one location to another location. Arithmetic instructions, we will be performing some of the arithmetical operations like addition, subtraction, multiplications, etc. The logical instructions, basically we'll be concentrating about some of the basic gates like AND gate, NOT gate, OR gate. So logical functions will be dealt using the logical instructions. Branch instructions, where jumping from one place to another, okay, you will be branching the location from one to another destination. And we'll also be concentrating on bit manipulation instructions, where a single bit is used to modify or change in the single bit is going to give you different features or like applications in using your instructions. And using all these instructions, we will be able to write a simple assembly level programs without loops. Okay. In module 3, we will be discussing more about 8051 stack, I/O port interfacing and programming. In stack, we have different operations and we will be analyzing all the operations like push and pop. And we also been studying about the subroutine instructions, and regarding the interfacing, using the I/O ports, we will be writing simple programs to interface LED switch to I/O ports. And here the assembly language program we will be writing using loops. In module 4, we will be concentrating more on 8051 timers and serial port communication, serial data communication. Different types of, we will be more concentrating on what is a timer, what is a counter, and different types of timers, and what are the different modes that each timer can be used. And second half of module 4, we will be talking about serial communication using RS-232 standard 9-pin signals. And we'll also be writing simple programs using assembly and C programming language in order to receive and transmit the data serially. In module 5, we will be analyzing about the concept called interrupt, definition of interrupt, and how basically the interrupts are being utilized in interfacing applications, and what are the internal interrupts, external interrupts, different types of interrupts, and maskable, non-maskable interrupts. All these things will be dealt in module 5. In 8051 interfacing applications, here we will be dealing with simple programs to generate waveforms, and in order to, we'll also be interfacing with the ADCs, DAC, LCD, and stepper motor, and we'll also be writing some small programs to interface all these peripheral devices. Now, the textbooks you are supposed to refer is 8051 Microcontroller and Embedded System using Assembly and C by Muhammad Ali Mazidi and Janice Zilibs Mazidi. The second textbook to be referred is 8051 Microcontroller by Kenneth J. Ayala. The other two textbooks are the reference textbooks as per the curriculum, and you can refer most of the contents even from these two textbooks. 8051 Microcontroller based Embedded Systems by Manish K. Patel and Microcontrollers by Raj Kamal. After the course, after the subject is completed, the student will be able to explain the different concepts related to microcontroller, which comprises of difference between microprocessor and microcontrollers, architecture, and he'll also be able to explain the interfacing of 8051 to external memories, and they'll be in a position to tell about the instruction sets. Using the instruction set, they'll be able to write the assembly level programs, and they'll be able to explain the interrupt system and how does an timer and a counter work, and how basically you are communicating serially. And they'll be able to write assembly level program as well as C programming to generate the timing waveforms, and some of the application oriented interfacing programs. And these are the outcomes at the end of this course. Let us talk about the basic introduction before we start with the topic of microcontroller. Introduction to computing. It comprises, we begin with, basically we start from number system. Human beings, we use normally base 10, that is decimal, hexadecimal, and octal, many other number systems. In generally, we use base 10, that is decimal arithmetic operations. That means like we use decimal number system to perform any operations. But computers, they use base 2, that is binary number system. Okay, so in this section, like we will be uh, trying to understand that in order to communicate with the computer processor, one has to convert a number system, one user-friendly number system, to a machine understandable number system, which is binary number system. Okay, and for which we should know the analysis of conversion of number systems. Okay, and to proceed further, in order to uh, develop a circuit, say for example, I want to generate an adder or a subtractor or any decoders. Okay, so we are mandatory to utilize the gates, logical gates, right? There are few basic gates and universal gates involved, and the basic gates comprises of and or not. The universal gates are like NAND, NOR, and even we'll be having XOR, XNOR also. Using all these logic gates, the binary logic operations are being like dealt, using which we'll be able to generate the simple digital circuits. Now let us talk about what basically the computer internally has. Consider the computer. We know that the computer comprises of a basic processor unit, central processing unit, we call it as CPU, which is the main part of my computer, which process or execute the information. Now, in order to process the information, processor should get the information or data which is to be processed. Now, the processor, where it will get the data, it tries to get the data from the storage devices, which we call it as memory. Memories are of now primary memory and secondary memory. Okay. So primary memory can be RAM, secondary memory can be ROM. When you tell it is primary memory, that is random access memory, it is the storage capacity is very less, and ROM, it is read-only memory. It is a mass storage or huge storage device. When a processor executes or processes the data will be fetched from primary memory first. If at all the data is not available in the RAM, then it looks or it searches the secondary memory where huge data will be stored. Soon after the processor fetches the information, then it tries to execute and send it to the peripheral device or the output device. Here the peripheral comprises of input-output devices, say we call it as monitor, keyboard, printers, etc. Now, how the data will be sent to these devices? The processor sends the data by knowing the address location of the particular device. The address will be unique for each and every device and location. No two devices will be having the same address. Now, in order to find out, or in order to send the address to the specific location, we make use of bus. Bus, it is the one which carries the information from one place to another place. We have different types of buses here. That is address bus, data bus, and control bus. Address bus is a group of address lines form the address bus. Here, once the CPU wants to fetch some information or load some information to the specific address location, it should place the address on the address bus. This address bus carries that information to the specified location which is meant, and once the address is pointed in a memory or maybe even in any peripherals, then the control bus will start informing whether to read or whether to write the data. That means a control bus, there will be a controller internally which is connected with one more bus that is called as control bus. Okay, let me call it as a control bus, and this is the one which is going to tell whether the data on the data bus is to be read or it is to be written. That means the information to be fetched or to be loaded. Now the data bus picks up the data either from or to the memory, which comprises of many data lines. Normally, the data bus size, the data size varies from 8 to 64 bits. That means if it is an 8-bit processor, it will be having 8 bits of data lines, and at a time it can process 8 bits of data. Say for example, I have 16 bits of processor, then the data bus will be of 16 bits. So at a time it can process 16 bit of data, and hence the performance would be better and faster compared to that of 8-bit processors. Say for example, even the supercomputers like Cray, it is having 64 bits of data lines, and it's a supercomputer just because the performance is faster, right? So how are you going to tell that the processor is faster? It is based on the data lines, the capability of the processor to process the information, the number of bits it is processed at a time. And here, yes, I think the three address bus, data bus, and control bus are being explained. Now let us move about okay. One of the most important features of computer is how much memory it has. Now we review the terms which is used to describe the amounts of memory in the computer or the PCs or the compatibles what we use, and we try to write the data size based on the number of bits the data can be processed. Before that, I'll tell what is binary digit. A binary digit, you can call it as a single bit, that is 0 or 1. You tell 1 byte it is equal to 8 bits. Okay, one nibble, it is nothing but 4 bits or half of your byte. And we have a terminology called word. Word is nothing but 2 bytes or 16 bits. Okay, so these are the various ways that we try to know the data size. Now, relative to the size of these, we also try to express the memory, okay, in terms of its size or in terms of how much memory it has. Fine, we try to tell it as like 1 KB. 1 KB, it is equal to 2 power 10 bytes. Then we try to represent using MB. Okay, which is equal to megabyte, which are around 2 power 20 bytes. And GB, it is like over 1 million, which is equal to 2 power 30 bytes. TB, it is 2 power 40 bytes, which is over more than 1 trillion. Now these are the terminologies that we try to use in order to express the size of the memory. Now with respect to memory, we have to understand the different types. One, basically we know it is primary memory, other one is the secondary memory. Primary memory is random access memory, and secondary we term ROM, that is read only memory. RAM, basically it is a temporary storage device which is used to store the data or the programs which is running temporarily. The data is lost when the computer is powered off or it is turned off. Now for this reason, RAM sometimes it is called as volatile memory. We are talking about the primary memories here, that is RAM. So we have secondary memory or secondary storage device, that is ROM. It contains the programs and information which is essential for to do the operation, and they are the permanent memory. We call it as secondary memory. It is permanent and cannot be changed by the user, and the data which is stored in the read-only memory it is not lost even when the power is turned off. That is why it is called as non-volatile memory. Now let us move on to the internal organization of computer. So basically we know that the computers are broken into 3 parts. One is CPU, memory and IBARO. The function of CPU is basically to execute or process the information which is stored in the memory. And we have split up the devices here. The RAM, ROM forms the memory section, and printer, disk, monitor, keyboard, all these forms the IBARO section, which basically used to provide a means of communication with CPU. Now the CPU is connected to this memory or IBARO devices through a wire which we call it as a bus. And we discussed about the different types of buses here, and it is shown with the lines of address bus, data bus and the control bus. Okay, so let us continue the topic in the next class. Thank you.